Okay, so this video is going to review how to solve a quadratic function, which you've done in Math 1 and then built on it in Math 2 and then touched on it again in Math 3. We're going to do things like root both sides of an equation. We're going to factor and set each factor equal to 0. We're going to refresh on the basics of completing the square and go much more in depth in that in pre-cal. And then we're just going to real quick review the quadratic formula, which honestly in pre-cal and calculus is your absolute last resort. So if you use the quadratic formula as a crutch to avoid having to factor or complete the square, then that's a habit that we need to break right now. Okay, so the first method is to solve by roots, and this is, that's not the technical term for it, it's what I call it. And look at number 1 and number 2, you can see that there is no bx term. So if this is your quadratic, it has the ax squared term and it has the constant, but it does not have the x term. And this is the only time when you can solve these by roots. So you're going to take number 1 and you're going to add 27 over to the other side, which is like very algebra 1 kind of basic. And then you're going to divide by 3, so you're getting the x squared by itself. And then right here, to undo a square, you are going to square root. So I'm going to square root both sides of the equation. Now the square and the square root on the x cancel each other out and just gives you an x. And then the square root of 9 is 3. However, technically, the square root of 9 has two different answers. The square root of 9 is 3 because 3 times 3 gives you 9. But there's another pair of numbers that when you multiply them together also gives you 9. Negative 3 times negative 3 gives you 9. So technically the square root of 9 could be a positive 3 or it could be a negative 3. It could be this or it could be this. So every time you do roots, every time you root both sides of an equation, like you introduce this root into the problem, you are going to have a plus or minus on your answer. So to do number 12, to do number 2, I'm going to subtract the 12 over. Okay, so this one is negative. I've got the square root by itself. I've got the square by itself. I'm going to square root both sides. The square and the square root cancel each other out. I'm going to go ahead and put my plus or minus so I don't forget it. And 12 has a 4 times a 3, and 4 is my square. So this is going to be like a 2 root 3, but what I am avoiding or what I haven't discussed yet is that negative. And from your previous math courses, you know that the square root of a negative 1 is I. So the way that we're going to write this is 2I root 3. Okay, so that one had a lot going on in it. So I'm just going to do one more real quick off to the side. So like if you had x squared plus, let me find a good one. Let's say 40. Okay, so I'm going to subtract the 40 over. I'm going to root both sides. I'm going to have my plus or minus because I rooted both sides. 40 is 4 times 10. And there's a negative, so that's going to be 2I root 10. If I had this, then I would add the 40 over, square root both sides, and I would get x equals plus or minus 2 root 10. So same thing, just no I, because there's no negative under the square root. Okay, so now for factoring. So I hope you can tell when you can just do this super easy method, which is just by isolating the x squared term and then rooting both sides, and that's when you don't have the bx term. Factoring is probably the most common way to solve an equation, to solve a quadratic by factoring. It must be equal to 0. So as you can look at these examples, number 1 is good, number 2 is not, 3 is good, 4 is good, 5 is not, 6 is not, 7 and 8 are not. So your first step 100% is to get it equal to 0. And then your second step is to factor. And so that's where you're going to GCF, you're going to do squares or cubes or trinomial, and that's where all that factoring knowledge comes into play. So this one is equal to 0. I'm going to GCF an x, and then I'm going to separate each one, set them each individually equal to 0, and then solve them. For number 2, I have to get it equal to 0 first. And again, I'm going fast because this is a review. So if you need to stop and rewind or slow down, please feel free. I'm going to GCF here an x. So that's going to give me x equals 0 and 4x minus 5 equals 0. This one's done. This one, I'm going to add 5 and divide by 4. And number 3, it's equal to 0. This is not a GCF. These are squares. So I'm going to have 3x and 3x and 5 and 5 and 1 plus and 1 minus. And then I set each one individually equal to 0. This one I'm going to subtract the 5 and divide by 3. And this one I'm going to add the 5 and divide by 3. So this answer you can see written as plus or minus 5/3, which should make you think of the previous method we did, which was roots. And on number 3, I totally could have done it that way. If I added the 25 over, divided by 9, and then rooted both sides, I could get plus or minus 5/3.